Section 3.4 Local extrema and the first derivative test. Objectives. The first one to define the increasing and decreasing intervals of a function. Next, to determine the critical values of a function. The last one to use the first derivative test to find local extrema of a function and use this information to sketch a graph of the function. Let's see the increasing decreasing interval of function. By definition, suppose that a function f is defined on the open interval ab. Definition number one, if x1 is less than x2, implies the function at x1 less than the function at x2. For every x1 and x2 on the open interval ab, then the function f of x is increasing on ab. Let's see the graph that you see on the screen. The left graph here, we have the interval AB. X1 is less than X2. X1 and X2 are within the point A and point B. Function value at X1 less than function value at X2 for all X1, X2 within the open interval AB. That means the function f of x is increasing on an open interval AB. And then the right graph is similar. The right graph, the point A, point B, or the open interval AB, x1 and x2, located within AB, function at x1 less than the function at x2 for all x1, x2 within the open interval AB. The graph of the function f of x is increasing. The left graph, the right graph, they both are increasing, but just increasing in different way, which we're going to talk more about that in the later chapter. For the second definition, if x1 less than x2 implies the function value at x1 greater than the function value of x2, which is opposite of the definition part 1. For every x1, x2 in the open interval AB, then the function is decreasing instead on an open interval AB. Let's look at this graph. Okay. So for this one, explained by the graph um, interval AB, x1 less than x2, but the function value of x1 is greater than the function value of x2. If this is true for all x1, x2 within the open interval AB, then the graph of the function f of x is decreasing, which is similar to the graph on the right. On the open interval AB, x1 less than x2, the function value of x1 higher than the function value of x2. The graph of the function f of x is decreasing for this interval AB. Next, the value of x for which a function is increasing or decreasing are always presented as open interval. These intervals are part or all of the domain of the function. So it means for the entire graph or the entire domain, the graph could be like increasing the whole domain or increasing just partial of the domain and then back to decreasing. So it depends on the function that we are working on. And the other part of the definition in the box here, use different color. The theorem supposes that the f of x is differentiable on the open interval AB, the f prime greater than 0 for all x in an open interval AB, then f is increasing. Where f prime is less than 0, the function is decreasing. Recall the derivative is the slope. F prime of x is the slope. And we know f prime of x is derivative of the function with respect to x. If the slope is positive, the graph is rising, so the graph is increasing. For the derivative or the slope less than zero, the graph is falling because the rate of change is decreasing. So that is the connection or the relation of the derivative and the behavior of the graph. So as the picture that you see over here, for the left graph, at one point the graph stopped increasing and then the graph becomes decreasing. And the increasing part, the derivative gonna be positive or the graph is increasing. And the other part where the graph is falling down, we have negative slope, or we just say the function is decreasing. And similar to the graph on the right side here, the left part, the graph is decreasing, the slope is negative. The right graph, the graph is increasing, so the slope is positive. In this example, the graph of y equals f of x is given. Find the intervals on which part A f is increasing and part B f is decreasing. Recall when we write the interval, it's gonna be in an open interval like AB. Like the left hand side is the open parenthesis, the right hand side is the closed parenthesis, no bracket. For the graph, the the portion that the graph is increasing, let's work from the left to the right. From point A to point B, yes, the graph increasing and then decreasing and start to increase again from C to D and after E and so forth. So we have three intervals that the graph is increasing. Just write it down. So A gonna be from A to B and then next gonna be C to D and the last interval gonna be starting from E all the way to infinity because the right end, it looks like it's keep going all over, but the left, they just start at A. And then for part B, where the graph is decreasing from the B to C, D to E, only two intervals that the graph is decreasing. So we write it as the interval BC and also the interval DE.